So this talk is this isn't a talk about where to place root servers. This is more of a business. I've been hearing a lot about attacks on the root server systems and some of the problems that the operators are going through, and I decided that I needed to have a better view into some of the business operations of root server operations and TLDs. So I started a little bit of research, and I basically took some of the publicly available information out there, rootservers.org, for example, and talked to a few people and came up with this talk. And this is extrapolated from a larger set of data that potentially will submit for St. Louis, depending upon how beat up I get from Bill. So, some demographics. Who and where are the people that operate root servers? Well, they're in the United States for the most part. Three corporate entities, A, C, and J. That's VeriSign, Z&J. C is Cogent, but I believe ISC is operating the Cogent instances. Two educational, one military, G, that's DoD, two research. It's interesting to note here that E and H are actually military instances, but they're both at research facilities, NASA and Aberdeen. And then there's three nonprofits, F, I, and L. F is ISC, I is Autonomica, and L is ICANN. There's a note here about Autonomica. They're definitely responsible for iRoot. There's some instances of iRoot that are hosted on a CDN. The CDN is a U.S. formed entity, which matters related to some conclusions in later slides. European Union, one nonprofit, K, which is RIPE in Japan, M, the WIDE project. And this is kind of what it looks like in terms of where the people that operate the systems are located versus where they're not located. So the margin of error here, again, this is a lightning talk, so it's a lightning presentation as well. This is probably a 5% margin of error, plus minus. So the conclusion here is 92% of root servers are operated by people in the United States and 8% are not. This is what it kind of breaks out to when you divide it up by what type of entity in the United States operates the root. So the non-US is obviously RIPE and WIDE, and the rest is broken out by nonprofit and corporations. Note the military number is 23% because I reconverged the two research instances back into the DoD NIC instance to come up with this slide. So where are these things? Well, they're everywhere. They're in about 54 countries, all religions and all methods of governance. So they're in the United States, obviously, democratic republics, dictatorships, kings, monarchies, you name it, they're pretty much there. Politically speaking, physical instances of the machines themselves, 79% appear to be located in democratic governments, 21% appear to be located in other types of governments. So, global diversification for security and performance. That's any CAS. Machines are spread throughout the world. Routes are announced in multiple routes are announced multiple instances. You go to the closest one, that one falls off the earth. You go to the next closest one. Different networks, different procedures, different software, different hardware, different weaknesses. That seems to be a good thing in this case. Well, let me back up here. I'm going to talk a little bit more about that good thing. So it seems to be that by not having an RFC define every single way that the root system operates or all of the procedures and allowing everybody to operate everything different is actually a strong point. So the weaknesses become strengths because of all the different hardware and all the different software. So for example, if there's a vulnerability in, let's say, Red Hat version 7.x, it's likely that not all root server operators are operating that same version of Unix across the globe, and it reduces the vulnerability, so to speak, of the system itself. I think it also makes it a little bit less a little bit less open to any kind of insider malfeasance. So, for example, disgruntled employees and whatnot. There may be some impact to a single instance related to some kind of malfeasance, but not likely to the whole system. Global distribution. This is kind of what it looks like in terms of where the systems are broken out by what I thought were the interesting continents, and I apologize for the typo on Antarctica. Thank you, Rob Seastrom, for pointing that out. This is in no way should be interpreted to reflect have or have not. So, for example, you see Africa has 2% here. In some hallway conversations last night with some of you folks, we pretty much concurred that this is pretty relative to the way that the internet is, that the traffic is dispersed, and it seems like it's a reasonable, that we're getting some reasonable coverage in the world. Not to say that it can't be better. So, situating a root server. So I'm not going to talk about how to route them and how to make the announcements and what kind of routers you should use, but basically it's actually pretty easy to get a location for a root server. There's no voodoo about it. There's a mutually beneficial relationship to operators and to network operators and root server operators. Basically, it comes down to who you know. You attend meetings, ICANN, operator meetings, IXs, and RIR meetings, and make relationships. Occasionally, the regulators will come to you and they will ask you to come and place an instance of a root server in their country. There's also a little bit of sales involved in the event, which some of the points that may or may not be well known is national pride. Countries like to have these things in their borders to serve their citizens. Also makes them feel like they have a little bit of control. Some of them have a lot of control. Performance and security and betterment of the user experience. So threats. There's no surprise here in the threats. Direct attacks, proxy attacks, botnets. We hear a lot about botnets, and Rick Weston's going to talk more about that from what I understand. And it's basically your average miscreant doing what they do. And I thought that, that's kind of interesting. Attacking the root server infrastructure is kind of interesting in its own right, because it's not clear what the motive is, because you're not really going to extort a nonprofit, because there's nothing to extort. So what are they really doing? Are they making us all look right while they run left and do something else? I think that remains to be seen. Hypothetically speaking, so let's conduct an attack on a root server. So there's no point in specifying which root server this is, but this is actually something that I personally was able to test out, and this is what I found. So target whatever root location in a hosting facility, a multi-post cabinet configuration with your typical cabling and power under the floor. Cabinet was unlocked, and the facility had single-factor entry. I entered the facility as a guest of someone else in my capacity of doing some business. So I got a tour of the facility, and someone pointed out, hey, that's so-and-so root server. So I opened the door, and no, I did not turn it off. But I was able to see the switch, the power strip switch, and I could have turned it off if I wanted to. Hijack attempt, this is pretty standard. Advertise a route and return bad answers. And then a network attack, spoof the source, random host queries, and send some packet love. This seems to be the attack of preference these days. So summary, the root system is less likely subject to some kind of insider exploit or attack in a single applicational exploit. It accidentally bust, as far as I can tell, not being on the inside of the root operator circle, and I think that's a good thing. I think that establishing any kind of tight standard and operational procedures is probably what's kept the system robust and operating to date. I think there's probably a lot of good research data coming across the interface of these systems, and that some of that data should be looked at more, perhaps a little bit more publicly. And trend. One of the trends I noticed in this research was that there's a little bit of collapsing of the system, and this is not really anything new. But it's interesting to note that there are some TLDs operating in the same platform configurations as root servers. So, for example, you have a root server in a platform with a hosted TLD, not necessarily on the same equipment. Done?
Yeah.
Okay, so we're done. So there you go. And I think these slides will be online.
I think we'll be after.
Any questions, any feedback? I would really appreciate
later.
it. Thank you.
Yeah, during the break.
Thank you.